Pre-Calculus Chapter 4 Lesson 5, and I wanted to do 3 or 4 examples of these tangent functions, looking at some shifts and how it affects those when we're graphing those. As a very quick review, we should remember that the period of the tangent function is pi. From the equation, we do pi over b in order to calculate what that period is. You remember we want to split the tangent function around the y-axis, so we're going to go half on the right side and half on the left side. That corresponds to the half of the circle, and then we'll go from there. So that's very important. Remember, our pattern is negative 1, 0, 1. All right, and we're going to need to split or divide the period into 4 equal parts in order to graph these. All right, so I think that covers all of the basics. We'll do a few examples, and if we run into anything, we'll make sure to remind you of those. So this is the parent function. I'm going to do this very quickly so we get an idea of what we want to do here. We know that there is no b value, so the period is pi. And we need to split that over the y-axis. So I need to split this in half. So I divide it by 2 or multiply by half, and I get pi over 2. So at pi over 2 on the right side of the y-axis, I'm going to have an asymptote. And then if I was doing this other side at pi over 2 on the left side, I would have an asymptote. And then once I have those two, then I simply go a distance of pi, and to repeat my pattern. So if I'm at pi over 2, I go pi over 2 here, or I go pi, so this would be another asymptote, the distance from here to here being pi. And then if I wanted to do another one, I would go out here, and then again I would probably be right about here if I was doing another one. Okay, so we split the first one around the y-axis, and then we take the period outside of that. Now, once we've done that, we want to divide this period into 4 equal sections. So let's do the one around the y-axis first. Well, this is nicely done because the y-axis is half of the period, so I simply have to divide each side in half, and I have my points. Now, if I want to label this, this is half of pi over 2, so this would be pi over 4, and this would be negative pi over 4, where these 45-degree angles are, and pi over 4 makes sense to me because that's the radian measure for a 45-90 triangle. We know the pattern is negative 1, so starting here at this value I'm at negative 1, at the next value I'm at 0, and then I'm at positive 1. So the first part of my graph is going to look like this. Right? And I didn't go out here further because the graph ends. I then do the next thing in the same period. So I take the period, I divide it in half, I take those halves and divide it in half, and then I know at the first one I'm at negative 1, at the next one I'm at 0, and at the next one I'm at positive 1. So then the graph is going to come through there and shoot up here. And then again, I would split this in half out here. This would be half, this would be half. This is at negative 1, then I'm at 0. So the graph would look something like this as it came out this way. Okay, so that would be how you would want to graph that, making sure that we split that over the y-axis. So I'm going to scroll this up and see how we did with the answer key. And you can see I'm pretty darn close there. I'm pretty proud of that one. That's pretty good. All right, so let's go back then and do one maybe that has a shift or a translation or something like that. Let's do number 2. So yeah, that one looks kind of fun. All right, number 2 here, I have a vertical stretch. And what a vertical stretch does is it stretches the y values. And this is 3 times these normal y values. So the way to take care of a vertical stretch is to simply take those y values from our pattern, negative 1, 0, and 1, and multiply them by this vertical stretch. So this negative 1 is going to be negative 3. 3 times 0 is still going to be 0, and then 3 times 1 is going to be 3. So these are going to be my points at those intervals rather than the 1 and negative 1. Okay, so we split the first period in half, 0 being there. Here's those in half. Now again, instead of negative 1, I'm at negative 3 because it's been stretched vertically. 0 is still a 0, but the 1 has been stretched to 3. So this one's going to look more like this. So you can see when you stretch it out, that really stretches out that middle part. So it almost looks like a line as it's going through here. So then I would do the same for my next period. So this is at -3 at the first 45. Then we're at 0. And then we're at +3. And so then the graph repeats coming through here, looking something like this. And then this would be in half here and here. So here I'm at -3. I'm at 0. And then over here I'd be up at -3 or +3, excuse me. So then it would go something like that. Okay, so you can see how that stretch really stretches those out, so it really makes those look almost like a line as they're coming through here. And you see I did a pretty good job there. Okay, let's take a look at one that has maybe a horizontal stretches or shrink or something going on there. Let's take a look at number 4. It's got a horizontal shrink and also a vertical shrink. So let's see how that affects our graph. Okay. So I notice that this is a half, so again, those y values are going to be multiplied by a half. Whoops, I got ahead of myself there. This is a 1. So we multiply a half times these y values, so this is going to be at -1/2 then, 0, and +1/2, really shrinking that down. Now, this is a horizontal stretch of 3. Remember, this is the b value of 1/3. The stretch factor is the reciprocal of what I see, so it's going to be a stretch of 3. Meaning, rather than happening in pi, it's going to be happening in 3 pi. Now, I can figure that out. The period, you remember, is pi divided by the b value. B here is 1/3. To divide by a third, we multiply by the reciprocal, or 3, so we have the period is equal to 3 pi. So now remember that 3 pi, the initial one's going to have to be split around the y-axis. So 3 pi divided by 2 is 3 pi over 2. So I need to have 3 pi over 2 on this side, and then 3 pi over 2 on this side to split that tangent function around the y-axis. Now, how do I figure that out? 3 pi over 2. Well, if you kind of remember what we've done before, what does this mean? This means 3 pi over 2 angles. Okay, 3 90-degree angles. That's what that means. Now, as I look at the scale that they've given me here, I notice this is pi, so one of this, or halfway between, would be pi over 2. So each of these grid lines on my graph here is equal to pi over 2, and I need 3 of them on each side. So starting here, I go 1, 2, so there's 3 pi over 2 on the positive side, and then I would have 1, 2, 3, that would be 3 pi over 2 here on the negative side to split that over the y-axis. Now from there, I have a period of 3 pi, so I need to go 3 pi. Now, 2 grid lines is 1 pi, so I just need to count 6 of those. So here's 1, 2, that's 1 pi, 1, 2, that's 2 pi, 1, 2, that's 3 pi. So that's 3 pi from here to here. So now that I have that, I simply go ahead and divide it in half. So I have 1, 2, 3, 4, 5, 6 grid lines, so half of those would be 3. So that's half of the period. And then I have to divide this in half. And again, I'm counting grid lines, and it's just that easy. 1, 2, 3 grid lines, so half of that would be 1.5. So 1.5, that would be about right here. 1.5 would be about right here. I go 1.5 would be about right here. Then 1.5 should put me there, which it does, and 1.5 I'd be out over here. So now that I have this, I can go ahead and graph my values. Now again, because we have a shrink, we're going to be at -1/2. So at 0, we're at 0. When I get to the next 45, I'm at 1/2. So that's only about right here. So this is going to be really flattened out as it comes up here like this. Now over here, I'm at -1/2. Then I'm at 0. And then at the next 45, I'm at a +1/2. So you can see, as this comes up, it really gets flattened out here by that horizontal stretch of this way and also a vertical shrink. It really smashes it down and pulls it out so it really looks kind of wide. And then this would again come up here, it would start coming up here much like this one. So that's what that would look like, I think. I hope. Let's see. 2, 3, 4, and there we go. We got it pretty good. Not too bad. Whoops, let me get that straight. All right, so that's when you have a stretch and a shrink. All right, I'm going to do one more where we try to maybe do a whole bunch of things and see if we can't do that one. All right, let's see what else we have in store for us here. Let's do, ooh, this one looks fun. Let's do number 9. Let's do number 9. Yeah, it looks like fun. I know, I'm crazy, but it looks like fun to me. All right, we have a lot going on here. Now, this -1 looks out of place to me because usually these are on the other side. So I'm going to just go ahead and write it more like I like to see it. So I'm going to put this as 2 tangent, and then we've got theta over 3 plus pi over 3, and then we have the -1 out here. Okay, so that looks a little bit better. All right, so I have a vertical stretch of 2. So that means my values of -1, 0, and 1 are going to be multiplied by 2. So that means I'm going to be at -2, 0, and 1. Okay, that takes care of this. Now I have a b value of 1/3, which means I have a horizontal stretch of 3. So to determine the period, I do pi divided by 1/3, which means I multiply by the reciprocal. So my period again is 3 pi. Now again, to split that in half around the origin, I need to split it in half on each side. So 3 pi over 2 to the right of the origin and 3 pi over 2 to the left of the origin in order to center that there. Okay, so I've got 3 pi over 2. So again, I have the same scale I had before. So 1, 2, 3 pi over 2 puts me here. I'd have 3 pi over 2 on the other side, and then I need 3 pi. 1, 2, and then 3 pi would be right here. Okay, so 1 pi, 2 pi, 3 pi, right. Okay, so that takes care of the b value. Now, what's the shift? There's a horizontal shift here. But you remember, I can't see the shift until I factor out the 1/3. So I'm going to need to factor out, well, first of all, I need to get rid of these two asymptotes because they're in my way. So I need to factor out 1/3 in order to see what the shift is. So if I divide by 1/3, that means I multiply by 3. So this is going to be a shift pi. Okay, so this is actually a shift to the left pi units. Okay, so now that I can see the shift, I already have my asymptotes where they would be. I'm going to go ahead and shift them now, pi units to the left. So again, 2 of these grid lines is pi, so this needs to go 2 to the left. This one needs to go 2 to the left. And so now I've shifted everything 2 units to the left. Okay, now I have to go ahead and divide this in half and do everything that I would normally do. So again, there are 6 grid lines between here. So if I go 1, 2, 3 grid lines, that's going to be halfway between. So 1, 2, that would be out here somewhere. And I'm just going to do that so I get an idea on this other side. 1, 2, 3 would be about right here, let's say. And then if I divide those in half, I need a grid line and a half. So that puts me about right here. A grid line and a half puts me about right here. A grid line and a half puts me about right there. Grid line and a half puts me about right there. Okay, so now that I have these, I can go ahead and do my pattern. But I have to remember there's also a shift down out here. So after I move these, I'm going to have to make sure I do that shift. So at my first 45 marker, I'm down at -2 because of the vertical stretch, but then I have a shift down 1, so this point's going to be down here. The 0 point simply gets shifted down 1. And then this point has been stretched, so this point is at, I wrote that wrong. I hope you noticed that earlier. I'm glad I caught it here, but I don't want to start all the way over. So that should be a 2. So this should be over at, this 45-degree marker should be up at 2, but then it's a shift down of 1, so this value should be about right here. So then I can go ahead and draw this as it comes through here, looking something like that. Okay. Now over here I'm at the first 45 marker, so I'm down at -2, but I get a shift down 1, so that puts me down here. So this is going to go something like this. Okay, and then over here, now we got to count, remember we're going backwards, so this would be the one that's at 2, but I shift down 1, so this is going to be out here, so this one's going to look something like this. Alright, so that's a graph where we have almost everything going on except a reflection, but a reflection we would just flip everything over the x-axis, so I don't think that that's too difficult. So let's scroll down here and see how we did. Number 9, how'd we do? I can't quite scroll it down far enough. I'm going to have to move this up so we can get it. I run out of room on my screen, but you can see we have it in the right place, so we're in pretty good shape. Okay, so that's how you graph the tangent function. Hopefully those were helpful. Go ahead and rewatch those as many times as you need, and we'll pick up with the reciprocal functions in the next lesson.